Injection molding process parameters, universal parameters, injection parameters, changeover parameters, pack hold parameters, gate freeze, cooling parameters, recovery parameters, press movements, machine and universal parameters. Machine parameters are those that are able to be programmed into the machine controls during the injection stage. These do not describe with exactitude the dynamics of melt before it enters the mold. These could be injection speed, position of the screw, the injection's hydraulic pressure, and revolutions per minute during recovery. Universal parameters are those values that the melt experiences before entering the mold, which could be injection time, volume of the melt, plastic or melt injection pressure, and recovery time.
Which parameter should I use, universal or machine?
Both, though the ones that will make more sense for universal molders are the universal parameters. A universal parameter better describes the physical function of filling a mold. Let's look at some examples. The ideal filling time of a mold is independent of the injection unit's diameter and of its corresponding injection speed. Hydraulic injection pressure is distinct and less than the melt pressure or the plastic pressure. The screw's position represents a volume, a cubic quantity of melt that will occupy a space inside the mold after being injected. This melt volume could be uniquely related to position when the injection screw's diameter is provided.
Shouldn't the press control use universal parameters?
Definitely. Many manufacturers have realized this is necessary and are starting to convert. In some newer machines, it's common to see that the control has the option to work with either universal values, sometimes called absolute, or machine values.
Let's review.
Injection. We previously mentioned that, during the injection stage, we want to fill the mold to between 95 and 99% of its total volume. In this stage, filling the mold is achieved with a quick injection flow with the best melt properties. Injection machine parameter. Injection speed in units of inches per second or millimeters per second. Universal injection parameters. Injection time in units of seconds. Injection flow in units of cubic inches per second or cubic millimeters per second.
Why is injection flow a universal parameter?
Because the mold sees the amount of injected material in units of time. Think about it. Injection flow is composed of volume divided by time, and both of these are universal parameters.
How many speeds should I use during the injection stage?
We recommend only one injection speed, though there are molds that require speed profiles. For example, molds whose fill is not balanced, like family molds which create distinct parts at one time. Remember that a large number of existing molds were manufactured many years ago and are probably not in the best condition.
How do some molders use a slow speed at the end of injection in order to avoid having the screw bounce back?
We have encountered this situation and have resolved the problem by programming in a proper transfer position. In future presentations, we will discuss how to determine that proper transfer position.
Do we control injection pressure and time in the injection stage?
They are not controlled. However, during the injection stage, we do program pressure and time limits. These limits should not be reached during the injection stage, since their purpose is to protect the mold and the press. Remember, the injection stage is known as the speed control stage. Do not try to fill the mold 100% during the injection stage. A little more than 95% is the goal. During injection, the screw acts like a piston. Also during injection, the check ring moves against the injection unit, creating a seal so that melt cannot return to the screw.
Let's review.
Changeover. Changeover is what determines the end of the injection stage. Once the injection unit is filled more than 95%, the injection stage ends and the next stage, pack hold, begins. Injection machines can change over in 4 ways: time, position, pressure, and cavity sensor. Let's look at each one. Changeover by time measures the time from the beginning of injection until reaching the entered changeover time. Changeover by position measures displacement from the beginning of injection until reaching the entered changeover position. Changeover by pressure monitors the pressure until it reaches the entered changeover pressure. A temperature or pressure sensor is located close to the end of the fill area of the mold cavity or cavities. When the melt enters the cavity and reaches the sensor, a signal is sent to the press's controls indicating changeover.
Which changeover method should I use and why?
Universal molders prefer changeover by position, since this best guarantees the injection volume required by the mold.
Wouldn't changeover be more precise with the cavity sensor?
Yes, but we must remember that most molds do not possess that technology. For this reason, we recommend changeover by position. This type of sensor technology is gaining popularity. If your mold is so equipped, then changeover can be done by sensor. Machine changeover parameter. Changeover position. Units in inches or millimeters. Universal changeover parameter. Changeover volume. Units in cubic inches or cubic millimeters. Note: changeover by cavity sensor, temperature or pressure, is also universal.
Let's review.
Pack hold. In this stage, the screw continues acting as a piston, compressing additional melt into the cavities until filling the remainder that was not filled in the injection stage. Note: some molders call this stage pack, some call it hold, others divide it into pack and hold. Universal molders believe this is one stage that includes both. The pack hold stage is known as the pressure control stage. During this stage, we control pressure in order to achieve the proper weight of the molded parts, which universal molders call mass dimensions. Remember that mass dimensions are only a function of the quantity of material and should not be confused with dimensions that affect shrinkage. Manipulating the packing pressure guarantees dimensions that are a function of the material quantity. Machine pack parameter. Hydraulic pack pressure. Units in PSI or bars. Universal pack parameter. Plastic pack pressure. Units in PSI or bars. Remember, cavity pressure is also a universal parameter. Shrinkage will be controlled mainly during the cooling stage. During pack hold, we only control mass dimensions, the dimensions that are a function of the quantity of material. Gate freeze. Once the cavities are packed, the melt is held in place until the melt in the gate solidifies, creating a plug inside the cavities. The parameter that controls the gate seal is hold time, whose units are seconds. Hold time is both a machine and universal parameter.
How is it that some machine controls divide pack into 2 parts, pack and hold?
These separate the stages of pressure control and gate freeze. In addition to pressure and time, they consider pack speed.
Why doesn't universal molding consider hold?
It is considered, it's just not divided. We believe that hold time starts when injection finishes and ends after the gates have solidified.
Why doesn't universal molding consider pack speed?
For universal molders, pack is the stage used to control pressure and speed is the result, since it is physically impossible to simultaneously control both pressure and melt velocity. One is the result of the other. That is to say, if you control pressure, the result will be melt speed, and if you control melt speed, the result will be pressure.
What should we do with machines that come with pack and hold?
If it's possible, turn one off or adjust the time of the second pack option to 0.
Should I use multiple pack pressures?
We recommend only one pressure, though there are old molds that still require a second pressure. For example, a mold could require a primary pack pressure in order to guarantee mass dimensions and a second pressure to guarantee that the runner and sprue can be demolded. Normally, the last part that solidifies in the mold is the runner. And even if we don't mold runners, it still might be necessary to pack them in order to guarantee that they will demold. The cushion. The cushion is the small amount of plastic that always stays in front of the screw after packing ends.
Can the cushion be equal to 0?
Yes. However, it will invalidate the pack stage, and consequently, there will be no control over mass dimensions. The cushion should always exist. Remember, if you prematurely remove the pack pressure, the melt will return to the runner and possibly go as far as into the injection unit. If pack time extends too long, the molder ends up molding runners. During the pack stage, the check ring stays against the injection unit, sealing it and ensuring that the melt doesn't return to the screw.
Let's review.
Cooling. In this stage, we remove heat from the parts until we obtain parts that can be demolded with thermally accepted dimensions. The idea is to manipulate the removal of heat from the melt in order to control the thermal dimensions. Remember that a rapid cooling rate results in thicker walls and a slow cooling rate results in thinner walls. Cooling parameters. Temperature of the mold, units in degrees Fahrenheit or degrees Celsius. Cooling time, units in seconds. The temperature of the mold and cooling time are both machine and universal parameters. Familiarize yourself with your machine's controls, since some controls include pack time inside of the cooling time. Be careful with this stage. Extensive cooling times can result in costly processes. The idea is to manipulate both parameters, temperature and cooling time, in order to obtain the optimal dimensions.
Can the mold's temperature affect the pack time?
Yes, it can, since any change in the way heat is removed from the melt will have an effect on the time it takes for the gate to freeze.
How do we control the temperature of the mold?
We can change the temperature of the water that cools the mold cavities and sometimes even modify its flow. It is important to understand that the temperature of the water that enters the mold and the mold's metal temperature are distinct. Remember, thermal dimensions are a function of shrinkage and not a function of the amount of packed mass. Cold molds and extended cooling times will result in thicker walls. Hot molds and short cooling times will result in thinner walls. The speed with which heat is removed can affect other mechanical properties, such as rigidity, translucency, crystallinity, etc.
Let's review.
Recovery. The main objective of recovery, also called plastification or plasticizing, is to consistently produce a homogeneous melt. During recovery, the check ring moves to the front, permitting melt to pass in front of the screw. Remember that recovery happens at the same time as the cooling stage. Under normal conditions, recovery ends before cooling does. If cooling finishes first, the control will not allow the mold to open. This condition will extend the cooling time and consequently will also affect the thermal dimensions. Machine recovery parameters. Speed of recovery in revolutions per minute. Hydraulic back pressure in PSI or bars. Barrel temperature profile in degrees Fahrenheit or degrees Celsius. Screw recovery position in inches or millimeters. Universal recovery parameters. Recovery time in seconds. Plastic back pressure in PSI or bars. Melt temperature in degrees Fahrenheit or degrees Celsius. Recovery volume in cubic inches or cubic millimeters. Back pressure. Back pressure's objective is to create an opposing force against the free displacement of the screw during recovery. This force will reflect in the form of melt pressure. An increase in back pressure results in an increase in friction and an increase in the mixing capacity. An increase in recovery speed results in an increase in friction and a decrease in the recovery time.
Can thermoplastic melt be compressed?
Yes, it can. Some materials can be compressed more than 20%.
So an increase in back pressure also results in an increase in the amount of injected material.
Correct, since more plastic will be compacted into the same volume inside the injection unit. Decompression after recovery. This decompression is achieved by slightly displacing the screw in the direction of the screw's recovery. During recovery, the mold is closed and full of material. It is this material that keeps the melt inside the injection unit. After recovery, the melt is compressed. If the mold opens and demolds the finished parts, the melt could drool inside the open mold. This is why there must be decompression after recovery. There can also be decompression before recovery.
How can there be decompression before recovery if the injection unit is practically empty?
Though not so common, in some molds this movement helps with sprue removal. Remember, if the mold opens during recovery and neither the injector nor the mold includes some valve system for closing, the plastic will drool inside the mold. As a general rule, recovery should end about 1 second before cooling does. It's important to know that the injection unit uses 2 sources of heat in order to melt the plastic: heater bands and friction. Though the operator programs the heat zones of the barrel, the melt temperature is the most significant factor.
Let's review.
Press movements. The movements of the press are simple. However, you must be careful during their adjustments or expensive breakage could occur. Each machine has unique programming, and you are responsible for learning and understanding your control's operation before using it. Let's look at the basic sequence. The mold opens. The cores on molds which contain them open. The molded parts are ejected. The cores go back into place if they exist. The mold starts closing. The mold protection stage begins and the clamping force is completed. The mold opens. Permission to open the press occurs after ending the cooling stage and, in the majority of molds, after recovery has ended. The fixed platen is not shown. The most significant parameters at this point are speed and opening position. Remove the cores. Not every mold needs this stage. Cores are mostly used in molds in which the cavity has to open or disarm in order for the parts to be ejected. This type of disarming is operated by an external mechanism, either hydraulic or electromechanical. This operation can occur as the mold opens. Ejecting the parts. Normally, the molded parts and their runners are held by the mold. and their removal depends upon some type of ejection mechanism. The finished parts are ejected by means of ejector pins, ejector plates, etc. This operation can occur while the mold is opening, also called ejecting on the fly, or after the mold is completely open. It is common to see mechanical arms or robots removing the molded components. At this time, the most significant parameters are speed and ejection displacement. Relocating the cores. Any molds containing cores must have them returned to their position before the mold can close. It is important to have some signal that verifies the complete relocation of the cores. If the mold closes with the cores out of place, it can break. Mold closing. Once the cores and the platens are in place, the mold begins to close. At this point, the most significant parameters are the speed profile and the positions of the mold. Mold protection. Protecting the mold is extremely important and must be set in such a way as to detect any difficulty in clamping, which may be due to some trapped object, so that the mold does not get damaged. Some of the most significant parameters are the protection zone, time limit, and force limit. For example, during the protection zone, the press will stop closing if the force limit or the time limit is reached. Clamping force. Once the mold protection stage has passed, the press will continue to close until reaching the adjusted clamping force. Clamping force is adjusted according to the mold's requirements. You can never be too careful. Understand your mold and the machine controls before trying to operate the press. Follow all safety rules provided by the equipment manufacturer and established by your company.
You have completed this lesson.